In this video, we're gonna do t-interval for one mean. In the last video, we did t-test for one mean, and in here, we're gonna create one sample t-interval. This is also a question that I pulled out from the book, Corn Soil Blend, which in this question, we're just gonna abbreviate it as CSB. So before we jump right in, I want to go over some key terms with you guys about like different tests and intervals that we're going to do a lot, especially important in AP stats. And oh, that's funny right here. Okay, so what is S or S sub x? That is sample standard deviation. And what is delta or delta sub x? This is the population standard deviation. Make sure to see the difference. If it's only a S or S sub x, this is for sample. If it's a delta, which is a Greek letter, or delta sub x, is for population. SE, or standard error, or you can say it as delta sub x bar. This is the standard deviation of sampling distribution. And this is also the thing that we've been using for t-test and t-interval a lot, right here. Below is the delta sub p hat. This stands for standard deviation of sampling distribution of proportions. You can see that what does it really mean to take sampling distribution? Sampling distribution literally just meaning you create a distribution of the samples. And basically when you collect repeatedly many samples and create and create the confidence interval for each, then you collect all of the intervals, and if we're doing mean, then this is x bar, and you collect a lot of the x bar together and they create a distribution, which is a normal curve at the end. Same for proportions. So let's take a look at this question, which is the main topic that we're going to introduce today. So first, take a second to read this question. So basically, like, all of these paragraphs doesn't really mean anything. What we're really going to focus is the question give us a data below, and what we're going to test for is actually the amount of vitamin C in the CSB corn soil blend from the actually from the US agency. I mean, like, they did the test for it, they did the experiment for it, but the unit is right here, and this is what we're really going to do, and n is 8. So what we're going to do is construct a 95% confidence interval for the mean amount of vitamin C in the CSB from this production run. So what we're really going to try to do right here is first set the mu, which is the average amount of vitamin C in milligrams per 100 grams in CSB, soil chrome blend, and create 95% T interval for one mean. The degrees of freedom is 7. This is n-1, and this is a simple random sample that we're taking, and there is more than 80 samples of CSB, meaning the 10% rule has been met. Therefore, we can go and create a box plot right here. I just copy and paste the screenshot. I just like, this is the screen, like how does it look like on the calculator. On the test, if you're going to draw a rough sketch by yourselves, you have to be sure to label all of the 5 points right here, which is the mean, which is the minimum Q1, no, this is median, and this is Q3, and this is maximum. Be sure to label the title of x-axis. In this case, it's the milligrams of vitamin C. And we're going to actually do some interpretation of this graph. Since n is 8, which is small, and data are symmetric, we can see it's roughly symmetric. You can argue it to be a little bit skewed to the left, but anyway, like, it's going to be work with t-model in this case. If you want to say that it's skewed left a little bit, then in your conclusion part, you have to mention, after you say what does the interval you just calculated means in this case, you're going to have to also do some interpretations of your previous questions raised right here, which is because the sample size is relatively small and the box plot is a little bit skewed to the left, the interval that we just created may be questionable. So that's how you say when the situation is like that. And we really want to show our work on how to get this interval. You can do all of those work on your calculator really easy, but just to make sure that you know what that formula looks like, the x bar plus or minus t star times standard error. And remember, we recall the previous videos when we were doing the z interval. This is how we do the z interval, and this is how we do a t interval. Pretty similar, which is x bar plus or minus t star times s over square root of n. And this is the standard error. Remember that we just reviewed the standard error right here, the notations and the definitions for it. So that's what we want to use in t-model to create our interval. Plug in all of the values. Those are all of the values that we got from the calculator, except sample size. And we got this interval. And finally, we're going to interpret our conclusion. We are 95% confident that the average amount of vitamin C in CSV is between 16.5 and 28.5 milligrams per 100 grams. Oh, and just forgot to say that in part 3, you can also show, you want to show that the normal curve right here, this is the interval that we just created. You don't really have to show the normal curve, but just to give you visualized explanation, I think it will be better to draw a curve right here. So remember that when you're doing a confidence interval, it's always a two-tailed interval. It always starts from the middle. So it means that we're really going to have two endpoints and create an interval. And that makes sense, right? So if it's a 0.95 confidence interval, then each end should be 1 minus 0.95 divided by 2, which give you 0.025. X bar and S, you can feel free to restate it right here. It will be better. It will be nice for you to restate that. So that's all for this question, and you can see it's not super long, and same 4 steps as we did previously. Nothing big changed, but just to make sure that you master all of the steps, and it will definitely be better for your school quiz or AP exam. Thank you so much for watching.